Hello everyone, welcome back to the channel. Recently I have received a comment about day and night cycle and I have decided to create a video about that, so big shout out to Eco Gaming for the idea. You're breathtaking. For this I'm using Unity version 2022.2, but it will work on any Unity LTS version. I have a project in URP and I'm going to use the skybox shader from Easy Stars video. I will link it in the description below. Then I have the post-processing volume with the modules bloom and tone mapping with the mode aces. Now with that out of the way, let me roll the intro. Okay, so in our skybox shader, let's make some adjustment first. Let me delete all these add nodes. Now we have our stars, our sky, our horizon and our ground. Let me make some room here and I will duplicate our sky colors multiply node. Let's create another color property for night sky. Call it night sky color. Give some default value. Drag it in and we will feed it here. Okay, we have our night sky and our day sky here. Now stars can be seen during night, so let's add our stars to our night sky. Let's also add our horizon and our ground path together. We have our night sky with stars and our day sky, and we want to blend between these two, so let's create a lerp node. Lerp stands for linear interpolation, so it will smoothly interpolate between inputs A and B depending on this time input or T. Take our day sky and feed it into first value A. Take our night sky and feed it into B. Now this input T has a valued range from 0 to 1. If we feed 0, it will take values from input A. If we feed 1, it will take values from B. If we feed 0.5, it will take 50% values from A and 50% values from B. If we feed 0.3, it will take 30% values from A and 7% from B, and so on. We can create a float property to control it from the inspector. Let's call it day-night slider. Set the mode to slider with range 0 to 1. Drag it in and feed it into input T. Finally, let's add these two together. Then take our add nodes output and feed it into base color block. Now we can control day and night with this slider. However, it is independent of our directional light. I want to control the day and night based on our directional light. To do that, we will use the directional light's direction and do a dot product operation with our world's up axis. So if our directional light's direction is parallel to our world's up, it will return 1. If it's perpendicular to our world's up, it will return 0, and if it's opposite to our world's up, it will return -1. In our shader graph, we no longer need this day and night slider, so let's delete it. Now to get our directional light's direction, we could use main light direction node, but there is a catch. It only seems to work on lit shaders and our skybox is unlit. So to get the direction, we will create a vector3 property. Call it main light direction Then we will feed the direction via script, so we don't need to set it as expose. So I will just uncheck it. Then let's create a small script. Let's call it get main light direction. Attach it to our directional light. In our script, let's grab the reference of our material, so private, because I don't want it to be accessed by any other class. Then type will be material. Then let's call it skybox material. To access it from the inspector, let's throw in the serialized field attribute. Then in the update, let's set the direction, so skybox material.setVector. Because our property is type of vector 3, then we need to give the identifier of our property, so we will just copy this reference and paste it here. Then feed the value of direction, so transform dot forward. I will also throw in execute in edit mode attribute, so it will execute even when we are not playing. That's it. Save our script. Let's drag our skybox material here. Now we have our main light direction. Drag it in, then take its output and feed it into dot product node. And the volts up is always going to be 0, 1, 0. Now this dot product node can output values from -1 to 1, but our input T accepts values from 0 to 1. So let's take our dot product node's output and feed it into remap node. Remap node will remap these values, which has original min-max from -1 to 1, and remaps them to 0 to 1. Then take our remap node's output and feed it into this input T. Now we can have day and night by rotating our directional light. It still feels a bit off, so let's add a sun. For that, let's use our main light direction. Let's also create a view direction node. It will give us normalized direction from our fragment or face to camera. Then we will take these two and feed it into dot product node. As discussed, it will return values from -1 to 1. We will take its output and feed it into arc cosine node. Arc cosine node is the inverse of cosine operation. For example, cosine of 90 equals 0, then the arc cosine of 0 equals 90. So basically it returns angle but in radians. Then we will create a float property, call it sun size, give a default value of 0.2, drag it in, and we will feed it into step node. Step node returns 1 if our input is greater than or equals to this edge, otherwise it returns 0. We will take our arc cosine node's output and feed it into this edge. Now I know this is a lot of maths, but stay with me and I will try to explain all this in a minute. In the meantime, why don't you guys hit that subscribe button? Okay, so in the step node we have our sun. Let's create a color property for our sun color. Call it sun color. Set the mode HDR. Give some default value, drag it in, we will multiply our sun color with our sun. Then I want our sun to exist only in the sky part, so we will take this power node's output and feed it into multiply node. Then we will feed this multiply into it. Now sun only shines during daytime, so let's add our sun with our day sky. Then take its output and feed it into lerp node's input A. That's it, save our graph. It will look something like this at the end. In the scene view we have our sun. Now let me try to explain all the maths that we did earlier. We have our directional light's direction, that is currently looking towards the camera or viewport. Then we used view direction, which will give us direction from our skybox fragments to camera or viewport in the scene view. And the dot product will return 1 for parallel vectors. So this point directly behind our directional light will return exactly 1. And then the further we go away, it will return less than 1 because skybox is a sphere. So assume this point returns 0.99. Let's see what is the value for arc cosine of 0.99. It's 0.14 something. We have set our sun size to 0.2, so in the step node it will return 1 because 0.2 is indeed greater than or equals to 0.14. Now assume this point returns dot product of 0.95. Let's see what is the value for arc cosine of 0.95. It's 0.317 something. So in the step node it will return 0 because 0.2 is not greater than or equals to 0.31. So that is the maths behind how our sun works. Seems a bit complicated at first, but it's not that difficult. Now we can control our day and night cycle by rotating our directional light. We can create a script that determines how long our day and night will be and rotate our directional light based on that. But I will leave that up to you guys. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.